Welcome, welcome. Here we are at banking part 2. I am actually going to zoom in a smidge here. Maybe make it a little bit easier for those with a lower screen resolution to see. So here we are going a little bit deeper into banking, and we are really jumping in on what compounding interest is and looking at APR and APY. So here is our banking project part 2. Video explanation coming soon. I'm recording it right now. Some required stuff to check out here. So here's a video just explaining some different information. There is an article as well here that I want you guys to check out, but don't feel like you need to read every single thing. I would say skim through and kind of focus on the things that you're less familiar with. There are also some old videos, one old video lesson here, and then a couple other videos you can check out if you'd like to. Here we have some articles you can check out, and then some open-ended questions. Again, these are things that hopefully from that information now you have a better idea of how to provide a sort of educated answer on, but again, it's kind of your own answer on it. Some guided practice items here. So part A is your answer, part B is the source. So basically just a URL link is fine for that, doesn't need to be anything fancy. And we get to the exploration section, which is where I'm going to be doing the bulk of this video, which is going to be a little Google Sheets mini lesson here. And then we wrap up with our conclusion, followed by a meme. So let's go into the actual Google Sheets portion. I have an example here for you, example 1, another example here 2, and then the 2 practice tabs are for you guys to do your work in. So on this tab, basically I'm looking at how we do different periodic rates and how they go from an APR to an APY. So APR is basically my annual percentage rate, whereas APY is my annual percentage yield. And we really want to understand what the difference is between those two things. My rate is just the flat rate that I quoted at, right? So I say I have a savings account and it earns 10%. And I'm like, cool. And somebody's like, I have a savings account and it earns 10%. Cool. And what really is important is that there's this second piece of information, which is how much, or I guess it was more properly stated, how frequently is that compounding? So how much does it compound? So basically there is this option to compound once a year, which is annually, 12 times a year, monthly, 52 times a year, weekly, and then I could compound daily. That's 365. I don't know why it says 356. Clearly, whoopsie, that is a typo on my part. There we go. Fix that a little bit. So when we're looking at these different period values here, it just is how often it's compounding within the given unit. So we're using years here. We could be talking about decades, and then the annual would actually be 10, but typically we're going to talk about things annually. So annually being just 1 and annual being 1 year. So here are the different periodic values. If I did something like, I don't know, biannually, then it would be 2 times a year. So there are some different variations we could do, but these are the most common ones. Quarterly, I would say, is also a pretty common one. Quarterly is doing it 4 times a year. So this APY multiplier here, so this multiplier is basically just the value that I could multiply something by if I said it was growing at 10% annually, right? So I could multiply it by 1.1. Now you may ask, how are you getting this 1.1 value? The 1.1 value is coming from this compounding interest formula here, and my n value is 1. So basically I'm doing 1 plus 0.1 divided by 1. Well, that 0.1 divided by 1 is just going to be 0.1. So it ends up being 1.1, and then raised to t time, I just did here, raised for the first year. So this is all just raised to the compounding factor, so the n value here. You could think about it as that times 1 if you want to. I'm just showing once annual here. So like with this next one here, we see it's raised to the 12th. This is 12 times 1, but I don't have the 1 explicitly there because it's just showing a single year value. I will show you down here how we can change that time value. So looking at this, we see if it compounds once, it's just the 1.1, but if I compound monthly, now I'm looking at 1.1047 blah, 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 blah. So a little bit more that we've earned because it's compounding sooner. So the sooner that it compounds, the sooner the money can build on itself. And that's why we love compounding interest. And that's why we hate it when we have a loan. So when we're looking at this value, if I were to talk about the APY, it's just going to subtract off that 1 value. So here I start at 10, end at 10 if it's only happening once a year. If it happens 12 times a year, my APR is going to be 10%, but my APY is 10.47%. So we kind of want to think about what the implication is for this. If I'm advertising a car loan, I'm probably much more likely to talk about APR, whereas if I advertise a savings account or investment of some sort, I'll advertise an APY. They're literally the same. It's just that one is sort of like tricking our brain into being lower, and one is kind of tricking our brain into being higher. So we want to be very careful when we talk about these things that we understand what they are. We want to understand that when my credit card says, oh, it's a 24% APR, blah, 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 compounds, monthly or daily or whatever, that's really a higher value. So just keep that in mind. We see weekly is a little bit higher, and then daily is even higher. If we did this at constantly compounding, we would use E, but we're not going to do a whole bunch of stuff like that in here. Just kind of a throwback to Algebra 2 there. So now let's look at how we can change the actual number of years in this. So here I have an example of I have $100 now. I'm going to invest it into an account, has 5% APR, and it's compounding monthly. So basically I want to fill in all these values. P is 100. My R is 5%. My N is 12 for monthly, and then T is 7 for 7 years. I want to know how much it will be worth in 7 years. If I change this to, let's say, 17 years, I see this value change here because I've got the formula all set up. The one thing I want you guys to note is that when I'm raising to an exponent, I have put that in parentheses. Our order of operation dictates that we call this thing out as it's being done so that we can have Google Sheets properly calculate it for us. So just take a note of that. So when we look at this, I'm saying B12, which is the $100, times 1 plus, and this is the 5% divided by 12. Now I'm closing that off, and I'm raising it to this B14 times B15. This is my N for 12, and T is 7. So this is raised to the 12 times 7. And that's where we get this value here of 141.8. So 141.80. If it does give us a really wonky value, so let's say, for example, I were to extend this out, that's okay. I'm going to let the formatting do the rounding for me. So this is keeping all of the accuracy that I want, and it's just rounding it to the nearest penny for me. Example 2 is where it gets a little bit gnarly, and this is why I've given you a full-blown example here, so when you get to practice 2, you don't kind of freak out. So in this example, I'm going to go over how a bank account is going to look like for a month, different transactions in and out, and with whatever the starting amount is. I'm going to start us out here with $600, but I will read through the example here. I'm going to just highlight what each column is doing, and I'm going to do that kind of one piece at a time. So the first part here is I'm looking at the date column. So here's my date column. It's just highlighting the days in the month all the way until I get to the first of the next month. I'm looking at the starting value here, the money coming in, the money going out, and I'm just doing an intraday balance here. You don't need to represent this intraday balance, but it is helpful when you're looking to apply fees, especially for a low balance fee. And then I have the ending amount, which is the end of the day. If there's no fees, the ending amount should be the same as the intraday amount. Each of these values are calculated with a formula, besides the first one here, which I have input from the problem. So I'm going to say we've got, let's see here. Yeah, right here. So trying to highlight it in the problem here for you. So Mr. G started his account with $600 as of July 1st. So that's where that value is coming from, and that's why it's a hard-coded value. From there on, though, it's going to be taking the previous ending value and multiplying by that daily interest rate, which we'll get to in a second. So let's take a step back here and let's take the problem in as a whole. I'm currently looking to look at my PHS Best Banking account here, and I am a checking account which has an APY of 5%. It's way higher than anything you'll ever actually find, but it makes the numbers a little bit nicer to work with, so there we go. I'm telling you that it's compounding daily. There's an overdraft fee. Overdraft happens when I pull negative on my account. So if I only have $5 in my account and I go to spend $10, I'm going to have my bank cover the $5 gap there, but then afterwards I'm going to have to pay back the $5 and pay a $25 fee on that. So we want to make sure we avoid those if at all possible. We have a minimum balance fee of $30 for under $150 in the account at any time during the month, and it's only charged once per month. So basically, at any point in the month, if I dip below $150, say I got like $110 at the end of the day, I'm going to get charged a $30 low balance fee. We have an ATM fee of $10. So this, it's bit of an odd example here, but I'm just trying to incorporate it for you. Typically, if you go to your own bank's ATMs, there's no fee. But here we're assuming, I don't know, we're going to some other bank's ATM, or maybe it's just a lousy bank. There is a monthly maintenance fee of $7 charged at the last day of the month, so we want to make sure we include that as well. And I'm starting out the account with $600 as of the 1st of July. I now have a number of different expenditures and money that I've got coming in. So I've got $40 for cookies on July 6th. I don't know what July 6th is. I think this should maybe say July 6th instead. And so clearly we see here why I'm a math teacher and not an English teacher. He has a $300 paycheck coming in on the 12th. Bought some magic beans for $800 on the 17th, and I found a $200 in a treasure chest or something, buried in the ground, and I deposited that on the 20th. So these different transactions that I'm naming off here are going to go in this in and out column here. Last is that we went and withdrew $20 from an ATM, got ice cream with cash, and that was on the 24th. So for those different transactions there, I've got the $40 going out right here, which is reflected right here. So this $40 on cookies on July 6th, that's where we see it right here, $40 spent on cookies. $300 that I got from my paycheck, that was July 12th. That's right here in the July 12th money in column. I now have $800 out that I spent on magic beans. I thought it was a wise investment, but it turned out not to be. I have $200 coming in for money that I found buried in the ground or whatever like that. And then I've got this $20 that I'm withdrawing from an ATM, and that's on the 24th. So I've got each of these values in and out represented here. I have one value highlighted in red here, and the reason I've highlighted it in red is this is the first time in the month that I've dipped below my monthly minimum balance. So my monthly minimum balance here, again, was $150 if I remember correctly. Yep, so $30 fee if I have less than $150 here. And that's where I add a $30 fee in here. I have a $10 fee from this $20 ATM transaction. So again, using an ATM cost me $10. So that's where these fees are coming from. And then I have $7 fee at the end of the month. This is from my monthly account maintenance fee, or whatever they're just charging us every month, $7. So let's get into how this is all calculated. And before I do that, I want to know what my daily rate is. So my daily rate is going to come from my APR. So my APR here is 5%. And so what that does is it takes the interest rate here, which is going to be compounded. What do I end up doing here? I didn't show it to you guys this way. This is one way of doing it. So basically, let's do it this way. No, I did tell you APY. I'll do this. So I'll tell you APY, and then I'll go back and maybe add like one more example here on example 1. So let's keep it as APY of 5%. And so how do I get the daily rate for this? I'm gonna show you an example 1 first. So let's add another example here. So let's go. Just going to show you real quick how I'm finding the APY. So for a daily rate, I just want to know for a single day. And so if I had an APY of 10%, I know that no matter what, I am yielding 10% here. So this is my interest rate. And then I've got my multiplier, which is 1 plus that thing. Whoops. It would be helpful if I put an equal sign in front there. So equals 1 plus this value here. And so that's basically what my annual rate's going to be. I'm going to leave that as a general number. And so when I'm looking at this multiplier, basically this is what it would be for the year. So if I wanted my period here to be daily, that's going to be 365. And so now I'm going to find my daily value as this multiplier, which is the yield for the year, so 1 plus whatever the APY interest rate is, and then I'm going to say raised to, and then it's going to be 1 divided by whatever my period is. So for example, if I wanted it monthly here, I'm going to do another example. So let's find the monthly rate of APY for 10%. My period now here is 12, and so here we see our monthly value. So if I were to take this and do it for an entire month, and month varies, so it's a little bit hard to compare like days to months, because some months have 30, some have 31, some have 29, that sort of deal. But in general, like if we raise this to 31st or whatever, we'd be ballpark for about this value here. So basically what I'm doing is I'm taking what I know to be the yield for the year, and I'm just breaking it down into a daily value. If I did this value raised to 365, it should bring me, back here to my 1.1, and I will show you that. So we'll do a little proof that it works. So I'm going to say equals this thing raised to, and then back to the periodic value, 365. So when I raise it to 365, I get back to the 1.1 here. I will do it again for my monthly value, and boom, there we go. So we see if I do raise it back to the same value, obviously we're going to come back to what that multiplying factor was. So now that we got that out of the way, let's jump back into this example. So basically I'm taking my APY. I know this is going to be an annual yield or a multiplier, so 1.5 here. And I will call this a multiplier. I've got 365 compounding because this thing is daily, and that's how I get my daily rate. So sorry to jump around a little bit there, but hopefully that makes more sense now, and that'll help put it in context later too. Here we now have the value, which I'm going to multiply from the end of the day here to the beginning of the day here. So we see at the end of the day, I ended up just basically doing the money I start with, add the money in, subtract the money out, and subtract any fees. If I wanted to, I could also do the interday value minus fees. And the reason I can do that is the interday value is just this starting value plus the money in minus the money out. So there's two ways of setting it up. I kind of just did this interday value as a demonstration. You don't need to use it. And so that's why I didn't use it in my actual end of the day value here. But you can go either way with it. So basically now I jump to my next cell, and now my formula's changed, right? So this is my just $600 that was going to be coming in. I will even highlight that yellow just so we can see that it is a fixed value. We've got input here. And so now I'm saying, well, what is this? This is going to be what I ended with yesterday times that daily rate. So that's how much interest this has compounded overnight. So we earned 8 cents on our $600. Woo, sweet, rolling in money here. So now I'm going to do the same thing, money in, money out, intraday value, no fees. So we end at the same that we started with. And now the next day, boom, I hit that interest. So you can kind of think about this in a couple different ways. Generally speaking though, this is a pretty simple way of doing it where we just add the interest at the end of the day and it's in the beginning value of the next day. If you wanted to add it to the end of the day here and then include this from this directly, you could set it up that way as well. It's kind of a preference style wise, but I'm just going to stick with this. So basically all the same boring stuff happening until I get to this $40 value. And here we can see by clicking into this cell here that it's coming from this $600.40 and then subtracting out $40, and that's how we end up at this $560.40. So no fees brings us to an end of day value at $560.40, and then boom, we get a little bit of interest on that. So as we're going through here, we've got the same deal, same deal, same deal. And this is an input value that we need to manually check for. So that's why I've highlighted this in red. So I don't have an awesome way of setting this up. I mean, I could set this up for any time the value here dips down less than 150 for the first time, that it's going to automatically include a 30 here, but those are kind of complex formulas that I didn't want to necessarily include on this project. So basically I'm just leaving it as a manual input value here. Same with the sort of $10 for ATM fee. We could have a different way of flagging it, but I'm going to avoid all that. So here, simplistically, this is our money going out. We have now hit an account balance of under 150, so we have a $30 low balance fee for that. And now I just continue going all through the month. Here we have our ATM fee, which is getting hit on this $20 we withdraw from the ATM. And then our monthly fee for $7 here. My final answer would be the remaining value at the end of the month, which is the beginning of the next month, which is going to be this $194.78. So if I wanted to say, blah, 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 what's the amount? I think I ask it somewhere. I don't ask it because it's an example, but I do ask it on the practice. So on the practice, it says, answer how much is in the account on September 1st and put that in the green cell. So just like to show you that's how the practice works versus the example I'm just showing you. So I guess I'm not asking you, but this is the account balance that I'd be looking for at the end of the month, now at the beginning of the next month. So August 1st starts with 194.78. And the real purpose of me kind of going through this is so you don't get overwhelmed, but everything is here. You can click through and see all the different formulas, all the different values. So when you're doing this on your own, practice 2 to me looks an awful lot like example 2, just saying. You can use that as sort of scaffolding for it. Here I've got a number of questions, so we're just going through how to make a sort of amount that I've deposited into such and such, do I have an interest rate here? Mr. G is going to deposit this money into Compost Daily. Let's do interest rate of, I don't know, 6%. Here we're converting APR to APY, and then here we're going to basically be building up to a certain value. So here we're going to have to apply a little bit of our own knowledge and work, and I don't want to give away too much here, but I would suggest maybe looking back at this example and playing around with this stuff right here. So here we're trying to find the ending value, and the ending value on this one is going to be $5,000. So I need 5,000, I have 2,000 deposited, and I'm asking how many years before we get there. So that's a sort of application of what we have in the example, but I didn't do it directly for you. But hopefully that stuff helps and you guys enjoy this banking project. We're going to be doing a lot with compounding interest going forward. It's really one of the most powerful things you can understand and hopefully take away from this class, is just to have a real appreciation of what it means to have the interest compound on itself. And so basically we've got money building on top of our money, and then it just continues going faster and faster, and we refer to this as exponential growth. Hope you guys enjoy the project, and I'm going to work on ending videos in an awkward way, so here we go.